Research teams are in upheaval. Harvard's renowned AVI Lobo has unveiled explosive discoveries regarding the enigmatic celestial body 3 Atlas hurtling through our solar neighborhood. What space agencies initially classified as a comet demonstrates impossible characteristics that leave Loeb deeply concerned. The object radiates energy equivalent to 10 nuclear facilities while maintaining a suspiciously precise trajectory near Earth. Could this truly be mere space debris? Or are we under surveillance? The reality proves more frightening than previously conceived. Unusual brightness pattern. The initial clear photographs of 3I Atlas captured by NASA's Hubble Space Telescope revealed something extraordinary that defies conventional understanding of comets and asteroids. The illumination distribution surrounding this entity violates established principles of celestial mechanics. Typical space debris such as comets exhibit luminosity that diminishes progressively as distance increases from their core, resembling a gradual descent down a coastal slope. The radiance decreases incrementally in smooth, predictable patterns that researchers can readily measure and comprehend. However, 3 Atlas operates under completely different principles. The luminosity surrounding it demonstrates no gradual fading whatsoever. Rather, it terminates abruptly and dramatically, comparable to stepping off a precipitous cliff edge. One instant reveals brilliant illumination followed immediately by complete darkness. This abrupt termination pattern precisely matches what researchers would anticipate observing if illumination originated from within the object itself, similar to a powerful beacon or energy generator rather than merely sunlight reflecting from its exterior. The phenomenon suggests something within 3I Atlas actively produces its own luminosity, subsequently illuminating the surrounding space. The Hubble photographs demonstrate this peculiar radiance concentrates at the object's forward section, oriented toward the Sun rather than trailing behind it as a comet's tail would appear. This positioning contradicts established knowledge regarding comet behavior, where material typically streams away from solar direction. Research teams attempted explaining this as surface dust evaporation, yet the calculations remain inconsistent. The manner in which illumination appears and vanishes so dramatically indicates something far more extraordinary occurring, something inexplicable through conventional space physics. This pattern represented the initial major warning signal that captured Loeb's focus and prompted speculation that we might be observing something truly unprecedented within our solar system, not merely another unusual comet, but potentially something artificially constructed. Nuclear power output. The most alarming revelation regarding 3 Atlas involves the enormous energy quantities it appears to produce. Following comprehensive analysis of data from numerous telescopes, Loeb determined this object generates energy equivalent to approximately 10 nuclear facilities operating at maximum capacity, roughly 10 gigawatts of sustained power. For perspective, this represents sufficient energy to supply a major metropolitan area. The Hiroshima explosion released approximately 15 kilotons of energy, while 3I Atlas produces equivalent power every few seconds continuously. This discovery truly triggers scientific alarm bells. Natural celestial bodies simply cannot generate such energy levels independently. Even the most brilliant comets previously observed fall far short of this output level. Comets radiate because they reflect sunlight from their surfaces and dust trails, they do not create independent illumination. Even more peculiar, this energy generation has remained constant throughout the object's journey, neither diminishing nor fluctuating as expected if it was simply ice melting or dust combusting. Something consistently produces massive energy quantities inside or around this entity. Loeb investigated every conceivable natural explanation for this energy signature. Could it represent a miniature black hole? Mathematical analysis demonstrates this would generate merely 20 nanowatts, millions of times insufficient. Could it be radioactive debris from a supernova? The universe lacks adequate loose radioactive material to account for it. After eliminating every natural possibility, Loeb reached a controversial determination: the only power source matching the data resembles something artificial, comparable to a nuclear reactor. The energy signature corresponds to expectations from controlled nuclear power generation rather than any natural process. This energy production level, stable, continuous, and massive, provides the strongest evidence suggesting 3 Atlas might be artificial rather than natural. Nothing within our current understanding of comets or asteroids explains how a space rock could independently generate such power. Size discrepancy. Among the most perplexing aspects of 3I Atlas involves determining its precise dimensions. This is where circumstances become truly intriguing. Initially, NASA researchers believed 3I Atlas must be enormous, approximately 20 kilometers across, roughly Manhattan's size, based on its apparent brightness from Earth. This would classify it among the largest comets ever documented. However, this created a substantial problem. Objects of such magnitude from beyond our solar system should transit through only once every 10,000 years approximately. The probability of observing one presently, merely 8 years after discovering Oumuamua, our first interstellar visitor, would be astronomically improbable, comparable to consecutive lottery victories. This is where Loeb's team achieved a breakthrough. They recognized that if the object generates independent illumination instead of merely reflecting sunlight, it could actually measure much smaller than initially calculated, perhaps just 100 meters across, approximately a football field in size. This completely transforms our understanding of the object. If it's actually much smaller than originally thought while still producing enormous energy, this makes its power output even more remarkable. The size calculation proves critical because it helps explain why this object might have been dispatched to our solar system. A smaller object would be considerably easier to accelerate to high velocities and control precisely, just as we humans would design space probes to be relatively compact and efficient rather than massive. If 3I Atlas indeed measures smaller than originally thought, it would match the profile of what we might expect from an artificial probe rather than a natural object. Its dimensions would be perfect for reconnaissance missions, large enough to house advanced equipment, yet small enough to be maneuverable and efficient. This dimensional discrepancy represents among the strongest pieces of evidence suggesting 3I Atlas might not be what it initially appeared. If it's a smaller object generating independent illumination rather than a massive comet reflecting sunlight, everything about our understanding transforms. Suspicious trajectory. Perhaps the most disturbing discovery about 3I Atlas involves its route through our solar system. Most comets and asteroids follow random, chaotic paths determined by gravitational forces and initial velocity. However, 3I Atlas appears to follow what Loeb terms a suspiciously perfect trajectory. His calculations reveal its path enables close passage by 4 planets, Earth, Mars, Venus, and Jupiter. Not merely one planet, which might occur by chance, but 4 major planets within our solar system. The probability of a random interstellar object coincidentally passing close to 4 planets remains incredibly small, less than 0.005%. Loeb emphasizes that in 99.995% of cases, such objects would simply zoom past without meaningful planetary encounters. What makes this even more suspicious is the trajectory's apparent perfect timing. When 3I Atlas reaches its closest point to Earth on December 19, it will be positioned on the Sun's opposite side, making clear observation impossible for us. This positioning appears almost deliberately designed to allow the object to observe Earth while preventing Earth from observing it, like someone wanting to study us while remaining hidden. Some astronomers argue this represents mere coincidence. But Loeb believes the mathematical odds against such perfect trajectory occurring by chance are astronomical. It appears as if the object follows a carefully plotted course through our solar system, designed to study our planets while avoiding close observation from Earth. This isn't merely unusual, it's statistically almost impossible without some form of guidance or intelligence directing it. While mainstream scientists continue searching for natural explanations, the numbers themselves paint a disturbing picture of what might truly be occurring. Strategic sun blocking. When 3I Atlas achieves its closest Earth approach on December 19, 2025, it will position itself on the Sun's opposite side from us. This perfect alignment ensures Earth's most powerful telescopes cannot observe it during the most critical moment of its solar system journey. Researchers remain puzzled by this timing. It resembles someone wanting to photograph you while deliberately positioning themselves behind a bright spotlight exactly when pressing the shutter button. You remain completely blinded while they obtain a perfect view of you. What makes astronomers like AVI Loeb suspicious involves how perfectly this positioning aligns with the object's trajectory. If 3I Atlas were randomly tumbling through space, the odds of it passing behind the Sun precisely during its closest Earth approach would be incredibly small. This strategic positioning creates a unidirectional observation situation. If any cameras or sensing equipment existed on 3I Atlas, they would have perfect views of Earth, fully illuminated by the sun. Meanwhile, Earth-based telescopes see nothing except blinding glare. Some scientists argue this represents mere coincidence. Objects passing through our solar system regularly get blocked by the sun at some point in their journey. However, what's unusual here involves the precise timing. It's not simply that the sun will block our view at some random point, but specifically during closest approach. This has forced space agencies to scramble, gathering as much data as possible before and after the December sun blocking event.